Welcome to our virtual field trip with Chandler Concrete. With over 40 ready-mix plants across 3 states, Chandler has been a family-owned and operated business for nearly 50 years. Today we'll be touring their ready-mix plant in Christiansburg, Virginia, as well as a dry batch plant located in Dublin, Virginia. There are 4 total plants in the New River Valley. One of the company's 2 block plants is also located in Christiansburg, although that isn't on our tour today. Chandler's vision is to be a well-respected industry leader whose brand contributes to sustainability and who improves the communities they serve. The company has a set of 9 guiding principles that lead to operations that are award-winning in terms of safety and sustainability. Our tour guide today is Mr. George Kuhn, Chandler's Technical Services Manager, and Hokie from Industrial and Systems Engineering in 1988. On today's tour, we'll look at the different types of plants, different approaches to materials management, the components that are used in concrete, mixing and batching, special products that are produced by Chandler, and we'll end with a little bit about the future of the industry. And like many of the other companies we visited this semester, Chandler has its own resident cats. Let's start our tour at their Dublin, Virginia plant, where we'll look at how a dry batch plant is set up and configured.
The truck actually will back under or pull under, depending on the configuration of the plant. They will pull under a silo typically, and everything is gravity fed down except for the aggregates. So you'll see a belt on the left side that is an incline belt, and that brings the aggregates over top of where the truck hopper is. So the loading process in a central mix plant is similar to this, except instead of the truck, all this is being done over top of a central mixer, and the central mixer would actually mix up the concrete, and then the finished product is loaded into the truck as opposed to the individual materials being put in a dry batch plant. Mm-hmm. Most of the plants, unless you're in larger areas, are dry batch type plants. The central mix plant is a much more costly installation, and you typically only see those in high volume markets. So the sequencing of this is that typically when you load a truck, you would put some of the water or the majority of the water and the admixtures in up front, and then the aggregates and the cement and pozzolans would all be loaded kind of in a ribbon feeding process so that they're blended as they're going in the truck. And the rotation of the drum allows those materials to be brought in, but it also facilitates the mixing. So a typical mixing cycle, once all the materials are in, will take 70 or more revolutions, and it pulls the material towards the front of the drum and then circulates it back over top of itself, and it's kind of a replenishing operation that thoroughly blends the product. But it takes probably a good 5 minutes or so of mixing to end up with a load of concrete at that point in time. In a central mix plant, that same loading process into the central mixer would only take about a minute or less of mixing.
So here's the conveyor that takes the aggregate up and prepares it, and you've got a bunch of different stockpiles of stuff.
Yeah, so this plant is similar but a little different than our central mix plant, not because of the nature of the type of plant, but just the nature of the way we set the plant up. Because of the capacity and the volumes we're running through our central mix plant, we basically automated that whole loading process, and the bins that are in the ground, which have an underground conveyor, it's all run by an automated material handling system. Here you see a hopper, and the loader will dump material into that hopper kind of manually, if you will, and it'll get carried up this incline conveyor all the way to the top of the building. And at that point, it's just like our central mix plant. They go into storage bins overhead where they are gravity fed into the scale to be loaded into the truck.
So what does all this look like from the batch operator's chair?
All right, so all of our plants are equipped with a computer that views our dispatch and ordering system. And what you see here, the green bars are our plants. So that's our Christiansburg Central Mix plant. This is our Dublin plant, which is where we are now. And under each of the plants, there's a series of bars that are orders. So this particular order is number 114. And underneath that, you will see a little indicator here that's a truck. Now, the way our dispatch system keeps up with things is when a truck is ticketed, it will appear on this side of the screen. And as it goes through its stages, it'll shift from left to right. So if you look up here, this truck on this order at Christiansburg is actually on his way to the job. Over here, this truck is in the process of unloading on the job. And then over here, these two trucks are actually on the way back to the plant. So as we get a multiple load order, you will see more than one of these underneath an order. If it's a single load order, there will only ever be one truck, and it'll just slide left to right. Once it's completed and the truck returns to the plant, that order will drop off the system and will no longer be visible. And as long as there's a truck on the job, these ones here that don't have any trucks under them are either not due to be loaded yet, or they're in a will call status or something like that. So what happens is, the first thing you'll do is you'll issue a ticket for a truck, and then it'll appear here, and then this ticket will be transmitted to the batch plant, which is on a different computer, and this works the same way at all of the plants that we have. So over here you have our batch system, and right here is the screen that basically is configured to show the plant. So here you have our ag scales, up here you have our cement scales, over here are all our admixture meters, and then this kind of simulates what the truck is backed under the plant, and this is the aggregate loading belt, and so it's kind of located and configured. So when the ticket gets sent over, which it just happened, you will get a batch setup screen, and so here it's showing the two trucks that were loaded previously. They're already finished, but this new ticket appears here, and here is the recipe for the mix design. And so the batch operator will take this and make any adjustments that they need, and depending on what's in there. So you can click on ticket setup and it'll tell you what's in the mix design. So this particular load needs accelerator and fibers and excuse me, that was a previous load. Let me click on the one now. Okay, so the one that just got ticketed needs just regular, there's nothing special being added into that. So you go to batch setup, and I can verify dosage rates of admixtures. If I want to use hot water, there's a tempered water, so I can change this and run, if I wanted to run 50% hot water, I can run 50% hot water. If I want to run nothing but cold water, I can just set this on 0. So based on what the customer has requested and paid for. So when you get this set up the way it needs to be, then you click on start, and then you will actually be able to watch graphically the cement gets weighed up, the aggregates are getting weighed up, and you can see by these bars over here the percent completion from left to right of 0 to 100 for each individual material and the scales themselves. So the cement scale is 60% of the way through everything that's going to be put into it, as is the case with the cement, and the aggregate is 40% of the way through, even though 2 of the aggregates are already completed weighing up, because I still have to do the coarse aggregate. So once the truck is under the plant, which it is now, I can click on the loading option, which is up here at the top of the screen. So if you can see it out there, you can see the truck down at the plant.
There's the truck.
And then I click on load, and you will hear a buzzer, which is a warning thing telling them the belts are going to start.
There it is.
I don't know if you can hear that.
Mm-hmm. Sounds like a motor
And then
noise.
now the belt has turned on, so now you will see the belt shows that it's running, and the water is now starting to go into the truck, which is the first thing that happens at a dry batch plant. And once all the materials are weighed up and the water gets in, then you'll see the ag scale open up, which there's an arrow indicating that it's opening up. You'll see the weight starting to drop on the ag scale. And then as part of the blending thing, once a little bit of the aggregate goes in, you'll see the cement scale open up, which it's done now.
and then you'll see the cement start to decrease as it starts to drop out of the cement scale. You can see it going in there. So now what you're getting is you're getting blending of the cement and the aggregate, and you can see that by the two scale percentages kind of going down in tandem with each other. So this is that blending of the aggregates and the cements in an effort to try to make it mix a little bit better. If I dumped all the aggregate in, then dumped all the cement, it would take a lot longer to mix than if I ribbon fed them in. And in a dry batch plant, because you're relying on 5 minutes of mixing on the drum, the more I can do to get the mix pre-blended as it goes in, the better and the quicker it will mix up. In a central mix plant, because of the efficiency of our mixers, speed is an issue, so we just throw it all in as fast as we can get it in there at one time, and the efficiency of the central mixer is such that it mixes it very rapidly. So this particular batch is a split batch. We're loading 10 yards of concrete here, and that's more material than I can get in either the cement or the aggregate scale, or a combination of both, in a single drop. So we split it into two batches, and you will see that it's completed the first one, so now it's weighing up the second drop, and now it's weighing up the aggregates for the second drop. And so first drop's already in the truck, and now it's starting to weigh the water for the second drop, and then it'll go through the same cycle we just did the first time.
Oh, cool.
And when it's completed, then it'll print a delivery ticket out here on our ticket printer, and that gets torn off and given to the driver to take to the customer, which serves as his invoice.
Cool. And I noticed some things happening over here on the cameras.
Yeah, this is, we have camera views at most every plant. This is our manual panel, which basically manually lets you override, but also indicates the same stuff we were seeing on the screen. The camera view, this is our ag scale, so you can see the materials dropping from the overhead bins into the aggregate scale itself. This is the turn head at the very top of the aggregate bins, where this incline belt, where that was the loading bucket out there, where the material would run up, go over top the bins and drop into the appropriate bin, and where it's pulled down by gravity into the scale when we weigh it up.
Very cool.
And at some of our plants, and in our central mix plant, you'll see where the material actually goes into the truck itself. So now you see the ag is starting to discharge, so you can see it pulling it down as it goes out of the bottom of the scale and up the loading belt into the truck itself.
Cool.
And I mentioned previously our admixture verification system. This green screen right here is the second meter for each of our admixtures. So in this particular case, we weighed up 102 ounces of our water reducer, and over here on our second meter, it got 103.1. So that 1 ounce variation is within the acceptable limits, and so there was no errors flagged. If one of these detected a difference, you would see this panel turn red, and it would be a warning indicator that we've got a malfunction in one of our admixtures. So
I see. Now let's have a look at how the central mix plant is configured.
So we built this facility specifically to take advantage of the volume that was going to be there, but we built it based on speed. At the time we built this, we put an 11-yard central mixer in place, and we could single drop batch a load of concrete and have it out the door in 2 or 3 minutes. And since then, we've done some maintenance. We've actually replaced our mixer with a smaller 5.5-yard mixer. So to do a full load of concrete, we actually have to load it in 2 drops. Because the speed is not quite as important now. We don't have quite the volumes going as we did during that 3 or 4 year period. But this plant was built so that you could drive in this concrete paving section, pick up your water if the drivers needed to add water to their side tanks. We had a rack there that you could put fibers in. Everything could be thrown into the truck. The trucks would pull around and then back under the plant, as you see the one in the distance backing under right now. And that taller structure on the right is our central mix, houses our central mixer and all the cement silos, and it would drop the finished product right on the truck. The advantages from speed of a central mix batch are once the truck's loaded, it essentially could pull right back out off the yard. There's no need to sit there and have additional mixing because the product's ready to go when it goes into the truck.
So what about environmental considerations?
Because even in a central mix environment, if you're dropping finished product into the hopper, the surfaces of the hopper are getting caked with concrete, and by washing that off, you can keep it from getting built up.
So what happens to your wash water? How do y'all treat that?
We collect it, and either through evaporation. It's used to wash the trucks out the end of the night. I mean, it's kind of a closed system. So
You allow the heavy stuff to settle out and then recover it?
Yeah, we'll all the fines will settle to the bottom of the collection pond, and then we'll dig that up, and then it becomes product that can be used for fill and other things like that.
Okay.
Just much like what we do, we crush our leftover concrete, we crush our block that are culls, and all of that stuff kind of goes into a waste stream and can be used for either road bases or fill areas.
Do you use any recycled aggregate as part of your product?
The problem with recycled aggregate is it's not consistent. If I get a load of flowable fill back or a load of 5,000 psi concrete back or 2,000 psi concrete that was made 2 days ago, they're going to have wildly varying strengths, and they're also going to have wildly varying gradations and compositions. And while we could do it and use a small amount of it, kind of to supplement, the consistency doesn't lend itself to, making kind of a first run product, knowing what you're going to get. And we don't have enough of a particular application. If you were in an urban market and you could count on a regular stream of that material coming in, it would make sense to add the cost element to process it and have that as a viable source. But the expense of us putting in a way to handle that for the little amount of product, I mean, I know you would think that there's a lot of product, and there is, but relative to the cost of processing it, it just doesn't make sense for us to try to use it in, particularly when we've got an avenue for how to get rid of it. If we were in an area where we didn't have a market for the crushed up material, then it might make some sense, in spite of the cost, to figure out a way to handle it and use it as a crushed up aggregate source. But we don't typically use the crushed material in a load of concrete. One of the main things that we do with it, if you look behind, you see these block, the wall divider block. We take leftover concrete, and the first thing we'll do with them when they come back is we keep forms on the yard, and we'll fill them with the actual concrete that's returned, and we'll cast barrier block out of them. That's our first use of returned concrete.
That is certainly useful.
Come out here in the shade a little bit. All right, so this is where the trucks will be loaded right here, and if they pull out and need to get tested, they'll back up right here. We've got a kind of a dump area for our testing samples that we can scoop back up with a loader bucket. And there's an overhead rack here that if we need to get up on top and add fibers or throw pigment into the load or look into the back of the truck, we can do that all right here. This is our admixture trailer behind that has all the tanks that hold our admixtures. And the big tank in the back is a treated water tank or a heated water tank. It's also it's an insulated water tank. It can hold either heated water or cooled water. We have a chiller that we can cool the water in the summer, and we have a heater inside that can heat the water in the winter. Concrete sets up as a function. It's a chemical reaction, so the hotter it is, the faster it sets. The colder it is, the slower it sets. And as we go through the weather cycles from spring to fall to summer, you get changes in the concrete temperatures. I mean, it's not uncommon in the winter, if we don't do anything different, for us to have concrete temperatures down in the 40s. And in the summer, we could have concrete temperatures in the 90s. Makes a huge difference in the set time of the concrete. So when they get out of about a 60 to 70 degree range and you need to bring the temperatures up, you do that by heating the water. If you get above 70 or 80 and you want to keep it so it's not setting up so fast, we can add chilled water, or we can even add ice in extreme hot water or hot weather events.
Wow. What's your fuel source for heating?
We heat with natural gas, and we use a technology called direct fired or direct contact hot water heating. So this is our stationary mixer, and this is a twin shaft mixer. It's actually got a shaft on the side closest to us and a shaft on the back side. The overhead box is a collection hopper where our aggregate comes in. Directly above that, you'll see the cement scale. That's where the cement drops into the stationary mixer. And on the far left side, there's a vertical pipe. There's a scale above that. That's our water scale. So all of the materials come into this facility above the stationary mixer, and then all get put into the mixer from the top. The twin shafts are a really efficient method of blending the materials together. And if you walk around this way, you can see the drive motors on the two twin shafts here on the end, and then over here you can see the collection hopper underneath the stationary mixer. And so the materials will go into the stationary mixer. The stationary mixer will mix the blend together. We can do up to 5.5 yards at a time. It'll blend it in a minute, and then it'll open the hopper underneath the stationary mixer and drop the material into this collection hopper. And then there's a gate at the bottom that we regulate to allow the material to go into the truck itself. And this is the incline conveyor that comes up from our aggregate scales on the other side of the building. And this is a 24-inch conveyor, which will very rapidly move the material to the top of the scale, or top of the mixer. So this is our batch office here, and there's a lot of camera views of basically our entire process. Over here you will see a camera that shows our loading hopper underneath the stationary mixer, and that's where the material goes down into the truck. This is our batch panel where we set up and load trucks. This is a manual panel that allows us to keep an eye on what's going on or override things. The sands that we use have a moisture probe so that you can adjust the moistures automatically instead of having to manually cook them off. And the values up here on the top two panels are showing the live sand readings of our two sands. Though it's kind of a microwave technology, it's actually detecting the moisture as it's flowing through into the scale when you weigh it up, and we calibrate those to. It's basically like a linear calibration system. So the more water that's in there, the more the detection system picks that up, and then it adjusts live as we batch from batch to batch. The coarse aggregates we have to adjust manually, and they're plugged into. The white panel on the wall back here is our automated material handling system for our ag bins. So these are the 6 overhead bins that I mentioned earlier, and this system in automatic mode has a probe at the top of each bin, and as the material pulls down and the probe becomes exposed, it'll automatically turn the system on, and then it'll run all the conveyors and open an outside gate and run the material up and keep it topped off so that we can just run continuously.
So you're ready to go. Are you a 6-day-a-week operation or 7?
At times. Rarely do we work on Sundays, but occasionally you'll have a customer that, due to their retail nature, they don't want to be shut down. So every once in a while we'll do something on a Sunday. Saturdays are a little bit more common, but primarily we're a 5-day-a-week business, but Saturdays come into play during the busier times of the year.
What kind of plant configurations might you see on the job?
Our batch computer pulls out of aggregate bins into an aggregate scale, the same whether it's a central mix plant or a dry batch plant. This plant, we have 4 overhead aggregate bins. Our Christiansburg plant has 6 overhead aggregate bins. Some of our other dry batch plants have 6 overhead bins. Typically, most plants will have 3 or 4 at least aggregate bins. Almost every plant has at least 2 overhead silos for the powdered material. Depending on the market, there could be a plant that only runs cement, and it may just have one overhead bin. A lot of times you'll see them that are, if they're set up specifically for an individual job, you would configure the plant just for the materials if you're going to run for that job. And the more bins and the more silos you have, the more costly the plant. So for example, if you were going to put an on-site plant to do a paving job and you were only going to use 1 sand and 1 stone and 1 cement, and the cement could be a blended cement. It could come with fly ash or slag already blended in, so you're running a pozzolan mix, but it's all coming in as a single product. You may set up a 2-bin, 1-silo plant, and that would probably be the least number of materials that you would ever put in for ready-mix concrete. There are some mixes that may use only one aggregate, and those are kind of specialized mixes. Sometimes they have larger pieces in the aggregate. Sometimes if you're doing grout, you may only have a sand. And in those cases, I mean, you may just have one bin that feeds the plant. It just depends on the job and the application. When you're dealing with ready mix, you're dealing with a variety of products that you're shipping. So the more bins you have, the more flexible you can be to the nature of the product. And the market's going to determine how flexible you need to be. More rural markets don't have as much variation as an urban market would.
So I noticed the materials out here are not covered, and I think they are at the Christiansburg plant, right?
Well, they have a roof over top. They're not covered. I mean, you can have rain blowing in. The reason we cover those in Christiansburg is to provide a little bit of radiant protection so that they don't heat up as much in the summer due to sunlight. And we do have a misting system over top of the bins in Christiansburg that allow for us to keep dust suppression and a little bit of cooling, and it also keeps our materials SSD, which is saturated surface dry, so that they're not sucking water out of the mix when we load it. Here we do the water by sprinklers, which becomes a challenge in the colder periods of the year.
I would think so. So what are the main important differences between a central mix plant and a dry batch plant?
And the difference between this and a dry batch plant is that it contains a stationary mixer inside of the building, and we load the stationary mixer, mix the batch of concrete, and put already mixed up ready mix concrete into the truck. The remainder of the plants in our corporation are the dry batch plants that put the materials in the truck, and the truck drum does the mixing. The other reason that a central mix plant is more consistent is the difference between the production personnel. I mean, at a dry batch plant, you've got one batch operator loading the trucks, but they can't see each individual load. The drivers become, in a sense, a mobile production operator. So at a central mix plant, you're putting the concrete into the truck, but it's already pre-made, and the driver just delivers it to the job. There are some fine adjustments that are done, but the batch operator at a central mix plant has pretty much complete control over the finished product because he can make the adjustments at the plant. In a dry batch plant, until it gets that 70 revolutions, it's not actually mixed up, and that occurs after the loading is complete, so the batch operator doesn't really see that. They would have to interface with the driver, but in effect, you've got every truck is its own production personnel, and that opens up some variation, so you get much more consistency with product coming out of a central mix plant.